G'day year 8s, hope you're having a good week. Well, in my absence, what you're going to be doing is some more work on algebra. And today what we'll look at is what's called factorising expressions. Now we've done the reverse of this because in the last lesson, what we did was we expanded brackets, okay? So what we were doing in the last lesson is we took this form of an expression here, this one here. What we did, remember, we called this the distributive law, and what we did was we said, well, this in effect means it's three lots of 4x and three lots of -5, and we stick them together. So we were writing this out as 3 times 4x plus 3 times -5. Recall that was 12x, and this is going to be positive times a negative is a negative, 3 5s are 15. So we call this form here, the one I'm going to highlight, we call this expanded form. All right, this is called expanded form. And this one here, this form here is called factorized form. Okay, and the reason we call it that is if I kind of ask you, well, what are the factors of 12? You go, oh, it's 4 by 3. So these are the factors that make up this number here. So what we've in effect is got two things multiplied together. So we call them factors of whatever this is. These are two factors of this number here. So that's why we call that factorized form. You're not going to see any great use in what we're doing yet, but we do start to pick up some of this algebra, and it becomes very useful when it comes to year 9 and year 10 mathematics. So these are important steps to learning how to start to deal with higher level problems that you're going to see next year and the year after. So if this is factorized form and this is expanded form, then the reverse is basically true. So expanded form would be 12x take away 15, and that is exactly the same, or can be written in factored form as 3 4x take 5. So again, to remind you what you were doing, in last lesson what we were doing is taking this and turning it into this. So this lesson, what we're going to be doing is taking an expanded form and turning it into factorized form. All right, so the first thing I want you to get down in your notes is the following, okay? And it will say here in your notes, to factorize, we run a 3-step process. Identify the highest common factor, HCF, of the terms. Write the highest common factor as a factor in front of the brackets. And then thirdly, divide each term in the expression by the highest common factor, writing the result inside the bracket. Okay, so I want that into your notes, even though at this stage you're probably not going to totally understand what that actually means. So pause the video here and add those sentences to your notes. Okay, so now that you've got them in your notes, what you're going to do is write out the example. So remember, I want you to write the words example and then the instruction. So it's very important that we have the instruction. The first set of examples will look at finding the highest common factor given two terms. Okay, so the first term we've been given is 12a. Whoops, I meant to highlight that, not cross it out. 12a, there it is there. And the second term is 18b. And what we're thinking about is we're thinking about the value or the number that will go into both of these terms, the highest possible number and or letter. So we can see here that we've got a 12 and an 18, all right? And I know something about those two numbers. When it comes to factors of 12, remember we've got 1 times 12, 2 times 6, 3 times 4. So there, those 6 things are the factors. Now 18, 1 times 18, 2 times 9, 3 times 6, and there are our factors. So we can see here that the highest common factor of 12 and 18 is 6. And we can note that there's no letter that both of the terms have in common. So that's all we're going to do. We're not going to take out anything else as a factor. All right, this one here is a bit harder. All right, so this one here, what we're going to note is that we've got a factor of these two terms here, 6 and 8. I know that the highest common factor of both of them, and you could do it like this, 1 times 6, 2 times 3, 8, 1 times 8, 2 times 4. And we can see here that the highest common factor is 2. So we're going to take the number 2 out. as a common factor. Right, now we look across the terms here and I can see a c squared and a c there. Now the highest common factor, okay, of these two is c. Okay, both of them have a c in common. This has got c times c and this has got c. So we're only going to take c out as a factor because both of them have a c in common. This has got two of them, this has got one of them. Okay, same with the d's. This has got a d, this has got d times d. So we're going to take d out, which is at least a common factor of both of them. And I'll try to demonstrate this as 6 times c times d, and this term here as 8 times c times d times d. So again, what we can see here is the number 2 is a factor of 6 and 8, but then we can also hopefully see that one of these c's they have in common and one of these d's they have in common. That's why I haven't taken out or claimed that d squared is a factor or c squared is a factor. It's just c and d. Alright, so pause the video here and make sure that you've got those two examples listed in your book. Okay, now that you've got those two examples, we'll go through our last set of examples. So again, I want you to get the words example, factorize the following expressions. Okay, so remember these are, or we can imagine that these are currently written in what we call expanded form. Okay, and what they want us to do is take it into factorized form. So we're going to follow this three-part process here. Okay, so the first step is so step 1, recall, is to ID HCF. Okay, that is, we want to know what the highest common factor of the two terms are. Now we notice that we've got 3 and a 3. This has got a y, but this doesn't. So all we're going to say is that we've got 3 as a common factor. All right. Write the HCF as the factor in front of the brackets. Okay, so we've identified it and I'm about to write it. So step 2 is write HCF in front of brackets. Alright, so now what we've got to do is divide each term in the expression by the highest common factor, writing the result inside the bracket. Okay, so the way you do this is you go, okay, well I've got 3y here, which is the first term, and I'm going to divide that by 3. Now 3y divided by 3 is simply y. Alright, I do the same over here where I've got positive 3 and I divide that by 3 and that is 1. So I'm pretty sure this is right, but you can actually test this quite easily by using the distributive law. So you just go back a lesson and go, okay, if this is correctly factorized, then if I re-expand it, it should return me exactly to there. So I'm just going to test it over here and see whether that's true. So the way I'm going to do it is do the distributive law. So 3 times y, I know that is 3y. Then positive 3 times positive 1 is positive 3. And notice that the two things come up exactly the same, that is exactly the same as that after we've re-expanded. So that's a very good sign that you've factorized correctly. All right, so the next example is this one here. So what we're going to do is look at the 10 and 12 and see if you can think about what the highest common factor of 10 and 12 is going to be. All right, and the answer is going to be 2. So we're going to put equals 2. Now we look for letters in common. This one has a P, this one has a P. So we're going to grab that as a common factor as well. This one's got a Q, but this doesn't, so we're going to leave the Q. And we've got an R and an R, so we're going to take that out as a common factor. All right, so over here now we've got 10 PQR, and I'm dividing that by 2 PR. All right, so I do 10 divided by 2, well that's 5. I do P divided by P, which is 1, so I'm not going to write that. I do Q divided by, well, there's nothing here, so it's just going to be Q. And I've got R divided by R, which is 1. So I think the answer, the first term, is going to be 5Q. And you can test it as you're going along by doing 2 times 5, which is 10, P, R times Q, PQR. So I know that I've got that right. Okay, now the second term, we're going to do negative 12 divided by 2, which is negative 6. All right, I've got a P and a P. Right, so that one would be P divided by P, which is 1, so I'm not going to write that down. And R divided by R is also 1. Okay, so we're going to leave it at that. And again, we can test this. So the way we're going to test it is re-multiply. So 5 times 2, we know that that's 10. PRQ is going to be PRQ or PQR. It doesn't matter about the order of the pronumerals. Positive times a negative is a negative. 2 times 6 is 12. And then we've got a PR at the end of that. And we can see that this so this thing here, the re-expanded version of the tested one, is exactly the same as the original. So that's a very good sign. All right, the last example is a tricky one, and there won't be anything this tough in the book, but I thought I'd cover it anyway. Now that's not supposed to be there, so let's just leave it as just C with these two terms here. So what we're going to do is try to think of the highest common factor of 15 and 10. Now we're going to note that both of these have negative numbers, or both have negative sign, but in particular, this first term has a negative sign out the front. So when we take out a common factor or find a common factor of it, what we're going to do is note that we're going to take a negative out first of all, and then we're going to take the common factor or the highest common factor of 15 and 10. Now that is going to be 5. All right, we open our brackets, so we've identified the highest common factor, and we say in this case it's going to be negative 5, because generally speaking what we want is the first term in the brackets to be positive. Okay, and again that's something you're going to see a little bit later on in maths. All right, so we've got negative 5, and we think, well, negative 5, a negative times a positive will give us a negative, okay, or a negative divided by a negative is a positive. So that's the starting point. Now I've got 15 divided by 5, which is 3, and b divided by nothing. So that's just going to be b. All right, let's just test it. Negative times a positive is a negative. 5 3s are 15 with a b on the end. So again, all the time when I'm doing this, I'm actually doing a lot of expanding in my mind, even if we are factorising. Okay, I've got negative 10 divided by negative 5. Now that's going to be positive 2. And then we've got c divided by 1 over here, or c divided by 1. So that's just going to be c. So I think that's the answer. And again, what we would do is test that to make sure we were correct. Negative times a positive is a negative. 5 3s are 15 with a b on the end. Negative times a positive is a negative. 5 times 2 is 10 with a c on the end. And again, it's always going to be a good sign if you return to that particular answer, return to the original expression after expanding. So once you test it, if that is the same as that, that's a very good sign that you've actually got the question correct. All right, so make sure you've got these 3 examples all written down in the book. You don't need to have this test here, okay? But each of the examples needs to be worked. All right, speaking of work, there's the questions I'd like you to do in class now. Good luck with that.